Hello and welcome to Vector Software Testing Symposium. My name is Andreas Horn and I'm Senior Manager for Code Testing Solutions at Vector. In the next 20 minutes, I will show you how you can get from visual to value so that data can drive your project. We'll talk about different ways how you can display your project data, both from a visual and from a tooling perspective. This will take us from tools you already have at hand over ready-to-use services to data intelligence solutions. The different visuals we will see along that path will help you to understand your project and derive actions from it, which will bring you forward. And the first thing I want to clarify is why should you prefer visualization of data? And then we will take a look at the different solutions, like mentioned, from a visual perspective and from a tooling perspective, solution at hand, in the cloud and on the build server, and then we'll come to the conclusion. But first, why do we need visuals? Because projects generate a lot of data that we could use to drive the project, but normally we don't because we are missing the overview. We have numbers, states, dates, links, results, categories, names, all that kind of information. But if we just look at the raw data, it is very difficult to make a sense out of it. Because we are looking for patterns, for directions, for distributions, and we cannot see this in the raw data. But if we use visualizations like bar charts, line charts, pie charts, then it's far easier to understand the data and to recognize how it develops, the distributions, the trends, and so on. So most people retain information better by seeing pictures rather than reading text. And so we should visualize data to see and understand what it means and derive actions from it. And the first solution I want to show you is a spreadsheet program, like you all should have, I suppose, on your computer. And normally this is just by using the data that you have on your PC, you copy that into your spreadsheet program and you generate a report that shows the result based on the data you have put in the report on your local machine. And so the analysis of data is done in a spreadsheet program. And there's already a lot that we can do in a spreadsheet program. Taking an example, simple visualization of a status distribution, status amounts, and so on. So we have a listing of different types of statuses and the number of issues that are in this status. Now we have already multiple options, and that depends on what we want to see in the data. If we want just to see the amount, then we can use a bar chart. That gives us a good impression how many of them are open, how many of them are done, and so on. And with the horizontal lines, we get a good orientation how many there are really. If we are interested in the distribution and the share of the status with relation to the total amount of data, then we can use a pie chart, because the pie is always representing 100%, and there we can see each piece of the pie represents a status, and the size of this piece is the share, the relation with respect to the total number of issues. So using these two, it is very easy to identify the current status, where we are. We only have one point in time. But now if we add the dimension of time to it, like here in this picture, you can see the dates of the project per month, and we can see what is the number of actual open issues that we had in this month. And if we now make this line chart, then we can see a trend. We can see that it goes in a certain direction. And now we can make use of that because we are always encouraged to plan ahead. So where do we want to be at a certain point in time? And we can add this plan data to the same chart. And now we can see if the trend that we have seen from the actual data matches with the idea of the plan that we had. So we can see where we are now, where are we heading, and with the plan we can also see where do we want to be. The history is in the data, just a reminder, we need that later on. What we can do also with the data we have Here, with the actual and the planned, we can derive information. For example, take the actual issues and the planned issues and divide that to show a kind of compliance indicator. And if we see this picture now, this gives us the relation of did we match the planned value to the actual value. And here we can see if this value is below 1, then we had actually less issues than planned. And if we are above 1, then we had more issues than planned. And here we see that from the trend and from the distribution, normally we had up to 20% more issues than planned. And from that, we can now derive actions and say, okay, we should put more effort in the resolution of issues if we want to achieve the target value in the end. Summarizing the spreadsheet solution, you have single location data, so all the information that is on one PC, on one desktop. You have various sources that can be analyzed, but the analysis is mostly limited to numbers. You could also analyze non-numerical values or non-numerical information, but this requires additional effort. The history is in the data. The visualization is done manually. You have to choose what you want to see. The report is static, and the update of the report is done manually. What do we have now as an option if we do not just have one location, but have multiple locations, and the information that we want to have in our report and the information we want to see is distributed over multiple machines? So we have parts of the information on machine 1, 2, and 3. But we want to have an aggregated result showing all the information in one report. For this, we can use, for example, a cloud service. I will call that a central data analysis. So the data is distributed across multiple locations. The data is aggregated in one location, for example, the cloud server, a service running in the cloud, and the report shows the aggregated result. How does this work? How can this work? We have the service running in the cloud and we have our tools, for example, the testing tool, and this tool pushes the information to the service in the cloud. And then the service itself generates visualizations, shows me the metrics, and so on. We can also include other information like results from analysis tools, and we can also show this. If we now put this in a continuous everything environment, so we push multiple versions, then we can also see trends. What we also can do is access this over a web app. This makes it possible to distribute also the information to different stakeholders. But this service can do even more because we can also connect this service to our source code repository to enhance the visualization that we have. I will give you one example. If you don't want to have the service to directly access your source code repository, then you can also use things like connectors running on your PC so that the service will not really get the information of your source code, but can use it for visualization. What we can achieve with that is an enhanced source code view, for example. It's an adapted visualization with detailed information, but it is also a combined view that is interactive. So here, for example, on top, we have an overview of the different metrics. Below, we have the details like the coverage information, the code findings, and we have the source code view in the middle. And this source code view is overlaid with additional information like the coverage information and issues. The issues are linked. So if you click on the details, you will go directly to the location in the source code. So this gives us the information related to the source code, and then we can take actions like rework the code with high issue density or review the parts of code with missing coverage. We also have other visualizations like this tree map you already have seen, and this gives us a combination of multiple dimensions. We have here a map per function that we want to test. The size of the blocks represents the number of statements. The bigger, the more statements. And the color is the percentage of coverage. So the darker, the higher the coverage. And so we get the information if we have covered all the functions by the color and how much effort it could be depending on the size. Here we can say, okay, there is a big function that is not fully covered, so I should prioritize large functions with low coverage, so this is the next point where I should attack. Summarizing this, with this cloud service solution, we have multiple location data, we have various sources that can be analyzed, but they have to be supported by the cloud service. The data can be aggregated, and now as we integrate this into the continuous everything environment, the history is in the service, no longer in the data that we have in one location. The visualization is done automatically, the report is dynamic, and the update of the report is also done automatically. But there's even a third solution that we could use here, because in a normal development environment, the developer accesses data on various locations, like servers, like shares, like cloud services, and so on. And the project is also using a build server that can access the same information. Normally, this is also where the CI environment is situated. And this server can already access the same data, and it uses it to build the deliverable software, to execute tests, to generate build reports, and so on. And so the logical next step is to also do the data analysis on this server, because there we already have all the information we need in one location. And additionally, we can also integrate this into the build pipeline, so it is updated with each build that is triggered on the build server. How are these data intelligence servers structured? I will give you one example. We have various formats of input data, and this is imported into the data intelligence server using providers or connectors. Then the data is consolidated, so we afterwards have tool-independent data, meaning we can have similar information from different kind of sources, and it will show up as the same kind of object in the data analysis server. Then we can also do data analytics with rating. I will show you one example of that. And based on this, we can do reviews, we can do quality gates, and we can do reports with visualization of data. Of course, we can do the same thing as before. We can show code coverage tree map that combines the code metrics and code coverage, like you have seen before. But now we can enhance this. We can include more information that we did not have before. Like code metrics, we can connect to the source code repository and take information from the repository, from the logs of the repository. We can include test execution dates and test result details. And so we can generate what can be called a to-be tested tree map, and it shows me with respect to code changes, test execution date, and so on, the functions where I should put more effort into to have them consistently tested. And we also have the possibility to filter these visuals on these servers so that we can, for example, focus on functions with negative trends, meaning functions that have gotten worse over the last builds, the last analysis runs. And then we have these visuals with applied filters that just show us the functions that fulfill our criteria. And so we can here clearly derive the action to prioritize functions with negative trend that need to be tested, so that we avoid further deterioration. Another visual that I want to show you is the so-called radar chart or Kvyat chart. And it's very easy to read. It shows us a set of metrics in a kind of spider web. And we have the target value where all of these values should be. And we have this line that shows us where the values currently are. So let me give you one example how this works. What we see here is a radar chart showing compliance with the so-called HIS metrics. And one of these HIS metrics is the language scope. And if we match the expectations of this language scope metric, then we make a green tick. If we fail, we get a red X. And then we just count the number of modules that meet the compliance, and we count the number of modules that do not meet the requirements of the language scope metric. And then we can compute a compliance to the language scope expectations. Here in this example, 91.7%. And now we are normalizing this using a rating scale. This rating scale is based on the percentage of compliance. And here you see lower and upper boundaries to map them to rating factors from G, which is the worst quality, to A, which is the highest quality. Here we have 91.7%, so this will bring us here in the middle, where we have an E rating for the language scope. And this is exactly what we then see here. E is the yellow ring, then we see the value of the language scope compliance. And like that, we can easily identify all the metrics that are not within target range, and we can also see the metrics that we already comply with, where we don't have to put additional effort into it. Groups of metrics can be evaluated on a common scale, and the outliers and problem areas can easily be identified here. The action improve metrics compliance, and then we can see which metrics we have to comply with. An additional thing that these analysis servers can do is implement analysis models that can even give us more information. What we see here is a list of code findings from static analysis tools. And what the data analysis tool, the data intelligence server, can do now is add information to that. It can add to each finding that we have a severity. It can map remediation cost based, for example, on experience. And it can map this to quality characteristics like reliability, performance efficiency, maintainability, portability. And using these quality characteristics, if we prioritize them, we come to the so-called scale pyramid of technical debt. So we can group the findings by characteristic and prioritize them. So if we want, for example, to achieve portability, this means we have to fix all the other issues before concerning maintainability, performance efficiency, reliability, and so on. So the technical debt that we see is normalized by remediation cost, and the findings are grouped and prioritized by characteristics. So this helps us taking actions like achieve reliability, and then we know exactly what to do. We have to resolve testability and reliability findings. And we are not limited to just one visualization at a time. We can also take multiple ones and put them on a dashboard to have the project at a glance. So here we have one example of a project dashboard. We have an overall rating based on the analysis result. We have key figures. We have charts that are related to requirements, to code, and to test. And this can be customized to your needs. We can even take one step further up and not just take a look at one project, but at different projects running on the same build server, being analyzed on the same data intelligence server. So we have a group that contains projects, and we have a rating and trend for each project. So here we see Mars and Sun project, both are rated D. Sun is going down from the trend. But we also have visualization of KPIs in comparison. There we can see this little dot that is the Sun project and the big red dot that is the Mars project. And so we can compare the projects, how they perform with respect to the visualization, with respect to the data analysis, and we can identify focus areas. And we can take the action, where do we want to put more efforts? Here, for example, Mars is looking worse than Sun, so we put the focus on the Mars project. Summarizing the data intelligence server, we can analyze multiple location data. The server is able to pull the information. Various sources can be analyzed. The data can be aggregated, consolidated, and combined. The history is again on the server. The visualization is done automatically. It can be combined on dashboards. The reports are dynamic, can be exported, and the update of the report is done automatically. Of course, these intelligence servers also offer the possibility to customize the model in which the data is analyzed, the visuals and dashboards. coming to the conclusion, visuals add value. And if we have data and visualize that, it makes the information, the data, understandable so that we can see trends, distributions, deviations, outliers, and status. We can even improve that by visualizing more data. This makes data comparable and combinable so that we can enhance information using information from different views. And adding data analytics, we can even make the data manageable using the visualizations because we have the possibility to visualize complex and complicated relations of information in a way that you can easily identify where we should focus next. So that we can take in the end actions like react on deviations, act to prevent further deterioration, prioritize efforts, or focus on certain projects. And this brings me to the end of the presentation, from visual to value, how data can drive your project. I would be pleased if you have taken away the following points. First, visualization is important because it makes data understandable. Second, already with available tools and ready-to-use services, you can use visualization to add value to your project. And third, by using data intelligence, you can enrich available data even more to make difficult correlations easily recognizable. I look forward to your questions and to meet you in the Q&A session. See you there.